This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired, and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches. So it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home, though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home. Not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe, too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
Frozen plains, icy mountains with their snow-capped tops glistening in the sun, valleys, craters, eternal freezing winter.
Wow. Hello there, Pluto. At first sight, it looks like a paradise for adventurers who love skiing, snowboarding, and all the other fun things you can do in snowy winter wonderlands. But the snow there is not like what you can find on the mountains of Earth. On Pluto, the mountain peaks are covered with frozen methane, while down here they're made of frozen water crystals. Because of its specific chemical composition, the snow on Pluto is red. The mountains themselves are very different too. They reach heights of up to almost 10,000 feet. But they're not rocky like ours, looking more like huge blocks of ice. Such a landscape cannot be found anywhere else in our solar system. But you'll need to pack some layers if you want to come visit. The average temperature there ranges from minus 375 to minus 400 degrees. When taking a look at it from a distance, you can see it has some kind of big, heart-shaped thing on its surface, called the Tombaugh Regio. That's actually a vast plain the size of Oklahoma or Texas that's covered in nitrogen ice. Scientists discovered this heart actually makes the winds of the planet blow. Craters are also big here, sometimes more than 160 miles in diameter, and some of them show signs of filling and erosion. Erosion is when land is worn away by natural forces such as wind, water, and ice. It's the same process that formed many interesting things that you can see on the surface of the Earth, like valleys, coastlines, peaks, or mountains. The fact that some craters are there because of erosion tells us that tectonic forces must be slowly changing the surface of Pluto. 1/3 of its surface is water, but not the kind that we like to drink, more like a really hard frozen ice. Water is vital for the evolution of life, but not water that's this cold, so it's unlikely that any life has formed here. At least for now. But how do we know all these things about Pluto? Well, here's the basics. Astronomers discovered Pluto in 1930, and just like with plenty other moons and planets, they named it after a figure from Roman mythology, the ruler of the underworld. Pluto was considered the 9th planet of our planetary system until 2006, after which it was recategorized as a dwarf planet. Despite its recent demotion, it is still the largest and the oldest known object in this region of the Kuiper Belt, an outer shell full of other dwarf planets and icy bodies. New Horizons. That was the name of the very first space probe that astronauts sent to have a look at Pluto in 2006. It reached a distance of up to 7,800 miles. While there, it took some important photographs and collected lots of important information, and discovered some of the mysterious cosmic oddities found on the surface of Pluto. One interesting thing about this former planet is that it sometimes has an atmosphere, and sometimes not. It has an oval-shaped orbit, which means, unlike most other planets, it doesn't travel around the sun in almost perfect circles. As a matter of fact, the sun is nowhere near the center of its orbit. When its orbit takes Pluto closer to the sun, the extra heat warms up a kind of thin atmosphere made primarily from nitrogen, an element our Earth also has in its atmosphere. Right after it's created, it gradually escapes Pluto's weak gravity. When the dwarf planet moves away from the sun, the atmosphere freezes and goes back to its solid state, falling back down to the surface of Pluto as nitrogen snowflakes. Pluto's interior is supposedly warmer than its surface. Some believe there's even an ocean deep underground. Despite being the largest known body in the Kuiper Belt, Pluto is still pretty small. It is smaller than the Earth's moon, around half the width of the United States. It has 5 spinning moons of its own, the biggest one half the size of Pluto itself. Our days last 24 hours, while one day on Pluto lasts 153. Earth needs 365 days to orbit the sun, while a year on Pluto lasts 248 Earth years. So, no birthdays there at all. It sits 3.6 billion miles from the sun, which is 40 times the distance of the Earth stands. If you were standing there, on Pluto, watching the night sky, you'd see the sun as just one small distant star, indistinguishable from the rest. Since Pluto has been demoted, Neptune is now the most distant planet of our solar system. It's also pretty fascinating. It's actually a huge ball of ice and gas. Yes, it's the densest gas giant in our solar system, but you still couldn't stand or walk on its surface. You would simply sink in. But if you could stand, you'd notice that the gravity force is similar to what we have on Earth. Despite its impressive size, though, Neptune is not visible to the naked eye from here. It's the windiest and coldest planet. And one year there lasts 165 Earth years. Still no birthdays. It takes more than 4 hours for the light coming from the sun to reach Neptune's surface. Our next gas giant is Uranus. 1 year on Uranus lasts 84 Earth years, so you can maybe get one birthday in there, but you better make it count. Just like Neptune, Uranus can't be seen without the help of advanced technology. The rest of the 6 planets can. But you can still see all 8 of them with binoculars or a smaller telescope. Now, pause the video, see if you can make your astronomy teacher proud, and try to remember which planet comes next in order from furthest to closest to the sun. You got it? That's right, it's Saturn. A+. Saturn is the 2nd biggest planet of our solar system, right behind Jupiter. And another gas giant where you'd sink in if you tried to walk on it. It's so gassy, you could put it in a lake and it would float. They call it the jewel of the solar system because it has a big ring system that kind of looks like a crown. Its rings are made up of dust, pieces of ice, and rock. Some of those pieces are as tiny as a grain of sand, while others are bigger than tall buildings. Next on the list, and completing our gas giant quartet, is Jupiter. Scientists call it a failed star since it's mostly made up of helium and hydrogen, just like the main star in our solar system, the Sun. But Jupiter doesn't have a mass big enough to start the chemical processes that turn it into a star. However, it is still the 5th brightest object in the solar system, right behind Mars. You probably have seen it when stargazing sometime, you just had no idea what it was. Okay, picture all the other planets combined and double their mass. That's a lot of mass, but Jupiter still has more mass than that. It's also the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Our day lasts 24 hours. Imagine how it would look like to squeeze sleep, work, family, friends, hobbies, movies, all that in just 10 hours. I guess I'd have to sleep once every other day if I lived there. Now, picture this. Magnificent tall mountains, giant dust storms, volcanoes, deep valleys, craters. Mars. That red jewel scientists keep talking about being a potential new home for us. There were even some small meteorite pieces found on Earth that scientists realized were ejected from Mars. That's how close we are. If you love sunsets, you would definitely enjoy the ones here because they're incredibly blue, while the daytime sky is pinkish red. But when on Mars, you'd only see the sun at half its size compared to what we see on Earth. And of course, there's Earth itself. Seas, mountains, valleys, waterfalls, and of course, light. For 4.5 billion years, Earth has been home to so many different kinds of organisms that have lived, died, and lived again. And even though we know so much about our homeland, there's always something new to discover each and every day. The next planet, Venus, is the champion of superlatives. The hottest surface, the closest planet to the Earth, the biggest number of volcanoes, 1,600. If you compare it to other planets to our solar system, the brightest planet, with reflective clouds that make it so shiny you can see it from the surface of Earth. Oh yeah, and the slowest spinning body as well. It takes 243 Earth days for Venus to make just one single turn. You could literally walk faster than the planet's rotational speed. Venus also goes in the opposite direction of Earth, so sunsets there are set in the east, sunrises in the west. And last, but not least, Mercury. It doesn't have any moons or rings, and it's the smallest planet in our solar system. A year there lasts only 88 days. So get ready to expand that birthday budget. Mercury is the planet the closest to the sun, but not the hottest. Venus took that title. Mercury is not the hottest because there's no atmosphere to trap the sun's heat there. But it does have wrinkles. Only 1/2 of Mercury's surface faces the sun at any given time, meaning there's an incredible difference in the temperature on either side, and of course these sides switch as the planet rotates. The iron core of this planet has cooled and contracted over millions of years due to the rapid change in heat, which is why wrinkles have appeared on its surface. Well, that's a brief tour of all the planets of our solar system. And one dwarf planet. Sorry, Pluto. Thanks for watching.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have 2 suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having 2 centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining X-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our 2-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.